Hello everyone, welcome to the test 3 Calc 1 test 3 preparation session, review session. And today we will be starting with critical number, increasing, decreasing, stuff like that. Okay. Now, first of all, let's make a graph. Okay. Um, if I have a curve like this, my points of influence, my critical numbers were basically the places where the graph has turned. Okay. And I got them by setting my derivative equal to 0, right? That's what I did. So starting again with it, I would like you guys to know what a critical number actually is. Why do we set it equal to 0? If I have f dash x equal to 0, how does that give me my critical numbers? Now, okay, tell me. Uh-huh. Am I not sharing my tablet? That's what you're supposed. See, 2 minutes. My God, I can't believe myself. Okay, okay. Let's say I have a graph like this. Let's start over. I have a graph like this, and the critical points are supposed to be the turning points. Okay. Now let's understand what a critical point actually is. Why do we set it equal to 0? For that, can somebody tell me what a derivative is graphically? What does that help me give me? It is the slope. So if you take a derivative of a function, right? Let's say x squared plus 3x plus 6, right? The derivative of that function, right? It would give me the tool to find the slope at any exact x point I want. If I set it equal to 0, what am I getting? I am getting all the points where the slope is 0. That means when my slope is flat. And that is why I set my derivative equal to 0 to get my critical points, where my slope becomes flat. When I change direction, at some point my slope would be flat. And that is why my critical point is equal to 0. Okay, are we good with that? Now, to explain further, I would like to start with an example so that I'm not getting, so that, I mean, increasing, decreasing stuff, it's best explained with an example. Before doing that, let's just know what increasing is. Increasing is when the graph is going up, and decreasing is when the graph is going down like this. Okay, we good with that? All right. Actually, let me make a duplicate of this. Let me keep this one. Oopsie. Let me keep this one over here. And let me take this one to the questions, problems. Okay. Local maximum. When I have a graph, I have several things with it. So the hills, these are called the local maximums, maximas, and the valleys are called local minimas. The portion where the graph is increasing, right? Where the graph is on an ascent, that is called increasing. So this is increasing, this is increasing, and this is increasing. The portion where the graph is going down like this, that is decreasing. Moving further, we have things called concavity. A shape like this is called concave down, and a shape like this is called concave up. We will get to know about all of this later on. I'm just giving an introduction right now. The points where the graph changes its curvature, it is called the points of inflection. So these dots, wherever they change the position, these are called points of inflection. Starting with an example, let's see. So if I go with 1, right, I have a function fx equals 4x cubed minus 6x squared minus 144x, right? I need to first find its uh, the intervals of increase and decrease. For that, what I do is that my first step is to find my critical points. These points, when the graph is flat and it's turning, these turning points. Okay, before beginning with that, let's know that what our domain is. Because our function is a polynomial, its domain is from minus infinity to plus infinity. This is necessary to check if our points of inflection, I mean, if our critical points are inside the are to be considered or not. Taking a derivative of this, I get 12x square minus 12x minus 144. Does that look right? Any questions so far? All right, good. Now, to find the critical points, all I do is that I set them equal to 0. Essentially, all I'm doing is that, hey, my derivative function, hey, the function that gives me the slope, give me the value of x when the slope is equal to 0, when there is a turning point. So I'm going to factor out of 12, and I'm going to get x square minus x minus 12 equals 0. This is going to give me x square minus x minus 12. All I need to do is to factor out them. Okay, 12. I need a number that multiplies up to 12 but adds up to negative 1. Multiplies up to negative 12. Can anybody think of those two numbers? 4 and 3. Perfect. So x square minus 3x, sorry, uh, minus 4x plus 3x minus 12, right? This would become x, factoring out x minus 4, factoring out 3, x minus 4 again. I get x plus 3 times x minus 4 equals 0. And my points of inflection are minus 3 and 4. That means I could have a local maximum or a local minimum at those points. Should we proceed on how to find them? Okay. So now let's make a number line. I have minus 3 over here. I have 4 over here. Alright, so now let's take this, bring this down, duplicate it. Now pick a number smaller than minus 3. Just if that's bigger than minus 3. Negative 4. Okay, now I don't need the well, like numerical value of it. If I plug negative 4 over here, would I get a positive or a negative? Uh-huh.
Wouldn't x also equal 0 for the like x we factored out?
So for x to be equal to 0, I would need an x that is separately over here. Because if I plug in 0 over here, right? That's 0 minus 0 minus 12. That wouldn't make my whole thing 0. That would make it negative 144. Whereas if I plug in 4 over here, right? If I plug in 4 over here, that's 4 minus 4, that's 0. 0 times anything would be 0 and it would make the equation 0. Does that answer your question?
Yes.
Alright. For anything to be equal to 0, I would need a factor of a factor alone without anything being added or subtracted to it. Okay, so we had minus 4, right? As the number.
Yes.
So plug in minus 4 over here. Do I get a negative answer or a positive answer?
Negative.
Negative, okay. What about over here?
0. Oh, negative. Negative.
Negative, right? So what's negative times negative?
Positive.
So this region becomes positive. Pick a number between negative 3 and 4.
Negative 2.
How about I make your life easier? Pick 0.
Oh, okay. 0.
Okay. Putting 0 over here, do you get a positive number or a negative number?
Positive.
Positive. What about over here?
Negative.
What's positive times negative?
Negative.
So you get negative for this region over here. All right. So now plug a number bigger than 4 over here.
5.
5. How
So
about 1 billion?
no. So
That's a,
that one
that's
is
that's a totally
positive.
that's a number you can use. So that's positive over here. Then subtract 4 from a billion is still a big number. Still positive. Positive
Mhm.
times positive is positive. Okay? All right. So now we have the like is the graph positive or negative over there. Now you can think of this as like think of make this shape in on the side. So let's say you have, I'm going to just use a line. Let's say you have something like this. Let's say you have something like this. And okay, so your graph is positive over here, right? So it's going like this. It's going like this, positive, positive. Oh, why is this not working? Let me connect my pen again. Okay, this should work now. Okay, so let's make a number line again. Becomes minus 3, 4. Okay, so from here, it's positive, it's increasing. Oh, that's why, because there's not page over there. So dumb. Okay, it's increasing over here, and then it decreases, right? Decreases, decreases, decreases till here. And then it starts to increase again. So the graph would look something like this. What did I say? The increasing, this is the local maximum are characterized by a hill, and the local minimums are characterized by a valley. Now, this is the graphical representation. If you want a shortcut, what I suggest is that look at that point of look at that critical value. The value beyond before it would be its maximum or minimum. So if the value before this is positive, it would be a local max. Max. If the value before the critical point is negative, it would be a local min. All right. So have we answered everything? Increase, decrease, as well as all the points of local maximum and minimum of the function. Okay. So now let's give the regions of increasing and decreasing. Increasing would be from negative infinity to negative 3, union 4 to infinity. And decreasing would be from negative 3 to negative 3 to 4. And we are done with this question. Does anyone have any questions?
I have a question. This is recorded, right?
Yep, this is recorded.
And then where can we find the recording?
I would share the recording with your instructors and you would be able to watch it from over there.
Thank you.
Mhm. Apart from that, does anyone have any questions regarding the material?
I don't.
All right. So, are we good to move ahead?
Yep.
Yes.
All right, so now that we are familiar with the decreasing, increasing test and we have found the local max and mins. By the way, that was the first derivative test to find the local max and min. Okay. Now let's move on and let's find what a concave up and concave down thing is. Oh, we can do it on the same graph. Okay. Now that we have this, let's take this thing again from here, from where we derivated it. To find the concave up and concave down, we're going to derivate the thing again. We're going to find its second derivative. Now it looks pretty much like the increasing decreasing, just the terminology has changed. Okay. So f dash x would be this. Now let's take a derivative again. What would I get? Does anyone want to volunteer? What would the second derivative look like?
It would be like 24x
Mm-hmm.
minus 12 minus 0.
Yep. So 24x minus 12, right? And now I want to find the points of inflection. Now what are points of inflections? If I go to my graph again, and let's make it over here. I had -3 and 4. So it was increasing over here, then decreasing, and then increasing again. The point, the point at which the graph changes its curvature basically goes from being concave down to concave up. That is called your point of inflection. Uh, Basically, like you can think of it as an arch, right? Think of it as a rainbow that is concave down. So it's like looking towards the down. It's empty towards the down. That's how I remember it. A concave down is just empty towards the down, and concave up is empty towards the up. Okay, that's concave down and concave up. Now, how to find it? Let's equate it equal to 0. So 0 equals 24x minus 12. Factor out the 12, you get 2x minus 1 equals 0. Divide by 12 on both sides, you get 2x minus 1 equals 0, which is x equals 1 over 2. So when x equals 1 over 2, then our graph changes its direction. So my final graph would look something like this. Okay, yeah. First I need to find what's point of what concave up and concave downs are of my equation. So I will need to make a line again. Over here, I'm gonna mark 1 over 2. Now, let's take this. Same thing. Pick a number smaller than half.
0.
0 works. If you plug 0 over here, do you get a positive or a negative number?
Negative.
Negative. If you plug in a number, okay, pick a number higher than 0. Sorry, higher than half. Higher than half. 10 or 1. Yeah, if you plug 1 over here, positive or negative?
Positive.
Positive. So the concave down region is the negative region. So concave down is minus infinity to half, and concave up is half to infinity. And that's your answer. Okay? And your point of inflection is half. So my final graph would look like this. So the increasing decreasing points were -3 and 4, -3 and 4, and I have a half in between. So my graph goes over here, increasing, 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 then decreases, passes through half, and changes its curvature. and then it goes to negative goes to 4, and then it increases, starts to increase again. This is what our final graph would look like. Does everybody understand?
Yes.
Any questions?
No.
All right. So that was the concavity test and the second derivative test. Wait, if dash is equal to 0 and this is greater than 0, and if it is greater than 1, then concave. Okay. The second derivative test, basically what it says is that at the points when your slope is flat, right? If your if your like second derivative, it has a positive value, that means it's concave up, then you have a local minimum. And if at like the point of slope, at your critical point, your second derivative's value is a negative, that means concave down, then it's a local maximum. That's all the second derivatives and derivative test says. Okay, are we good to go to section 4.4 L'Hopital rule? Because it's a big portion.
Yes.
All right. If at any point anyone has any doubts regarding the current topics, please let me know. Okay, L'Hopital rule. Now, the reason why L'Hopital rule was created was because to solve indeterminate types, okay? We would theoretically know what's 1 over 0. It's like 1 divided by a very big number. So it's something like 0, right? In limits, we know that from limits. We know that if we take 1 over 0 and the limit, right? If we take some limit, this is equal to 0. And infinity over 1, this is infinity. Like, these are like numbers that seem kind of like stupid or something. Like how is something infinity? But like we can mathematically describe them. That's the point. We can mathematically describe these numbers. 1 over 0, we see that it's undefined. We can mathematically describe this. But something like 0 over 0 or infinity over infinity, this doesn't make any sense. These are called indeterminate types. We cannot find what's infinity over infinity. We don't know what if it's 1 over 1 or something like that. Infinity is supposed to be the biggest number that we know. But the thing with math is that if you chase the biggest number, it's gonna get bigger and bigger. So that's why we don't know what these are. To solve this, we have the L'Hopital rule. Now, what does the L'Hopital rule says? The L'Hopital rule says that if you have fx over gx, right? And you have some limit x goes to a. If plugging in this limit, you get 0 over 0 or infinite over infinite, you can apply the L'Hopital rule. This is just the first requirement of the L'Hopital rule. To even get started, you must have these. You cannot apply L'Hopital rule if you do not first check these. If it's 1 over 0 or 0 over 1, 5 over 3, you cannot apply the L'Hopital rule. You can only apply them to 0 over 0 or infinite over infinite forms. Next, let's know what it is. Let's say if we checked and we have a 0 over 0 form or an infinite over infinite form, we take the derivative of the numerator and the denominator separately. So we get f dash x over g dash x, and x still goes to a. Now we will try plugging in the value again. If we get a conclusive answer and not a determinate type, then we stop over there. But if we continue to get an indeterminate type, we continue to use the L'Hopital rule. There are four different types of indeterminate forms. The first one is simple, infinite over infinite or 0 over 0. You can apply L'Hopital rule directly to this. The rest of them, we will be shifting stuff around to use the L'Hopital rule. We would be shifting stuff around to make them into 0 over 0 or infinite over infinite forms. Now fx, the next one is 0 times infinity, where we have something like fx times gx. And this, we make a smart choice and we reciprocate one of them. So we could make this gx over 1 over fx, f of x. They still are the same thing, but we have intelligently, we have taken a good guess and reciprocated one of them. Let's say this was 0 and this was infinite, right? Let's say this was 0 and this was infinite. Now, reciprocating this would become 1 over 0. So if we have infinite and undefined on the top and 1 over 0 on the bottom, which is also undefined, then it comes in the L'Hopital rule form. So that's why we reciprocate one of them. The next one is infinite minus infinite form. In this one, we would take a common denominator to use the L'Hopital rule. We'll learn about this later on. And the last one is 0 to the power infinity, infinity to the power 0, and 1 to the power infinity. In all of this, we would be using logs to find our answer. Let's first start with the type A. Let's pick a question. Then, who? Let's see. Let's pick 10A. Why not? We have sine x minus x plus 3x squared over 2x squared, and the limit x goes to 0. Our first step is to always plug in the limit. So I get sine 0 minus 0 plus 3 times 0 squared over 2 times 0 squared. Now, what's the value of sine 0?
Is it 1?
No,
Or is
the
it
value, it is 0. Sine 0 is 0, cos 0 is 1. Learning the unit circle values are absolutely essential. I would urge you guys to please, please, please know the unit circle values. Especially if you are taking Calculus 2 next time. Calculus 2 takes, but basically it expects you to master Calculus 1 and pre-calculus, both of them. I have a video of my own way to remember the unit circle values, which I can share you guys later on at the end of the session. But the value of sine 0 is 0. So I get 0 minus 0 plus 0 over 0, which is 0 over 0 form. Now that we have it in the 0 over 0 form, I know that I can use the L'Hopital rule. So now is when I'm allowed to use it. So I have limit x goes to 0 sine x minus x plus 3x square over 2x square. So this becomes, if we take a derivative of the top, this becomes, okay, what's the derivative of sine x? Come on, someone. Sine x derivative.
negative cosine?
Cosine of x. So derivative of sine x is cosine of x minus 1 plus 6x over 6x. Now let's try plugging in the value of 0 again, the value of the limit again. This becomes cos of 0 minus 1 plus 6 times 0 over 6 times 0. What's cos of 0?
1.
1 minus 1 plus 0 over 0, which becomes, oh no, it again became 0 over 0 form. No worries. As long as it is in the 0 over 0 form or infinite over infinite form, we can go ahead and use the L'Hopital rule again. So for this, let's use the L'Hopital rule again. I have limit x goes to 0 cos of x minus 1 plus 6x over 6x. Taking a derivative of this, I get negative sine x plus 6 over 6. Oh, sorry, yeah, 6. If I plug in the value of x again, I get sine of 0 plus 6 over 6, which is 6 over 6, which is 1. So, this is my end answer. This is my result in the end. Does anyone have any questions regarding this?
No.
No.
All right, perfect. Should I move on to the next form?
Yes.
All right. Moving on to the next form, I have 0 times infinity. Let's pick one of those questions. So, 0 times infinity. This is infinity over infinity again. This is 0 times infinity. Okay. So let's do 10f. Give me just 1 second.
Okay. Hopefully that works.
Okay. Now this is limit x goes to 3 to the 3 from the right, x minus 3 to the power 3 log of x minus 3. Now if I plug in, now my first thing to always do is plug in the value of x. So I get 3 minus 3 cubed log of 3 minus 3. So this becomes 0 and log of 0. Does anyone know the value of log of 0? Anyone? Okay. Let's know what's the graph of log of x. Log of x looks like this. It goes like this. So log of 0 starts at minus infinity from here. So log of 0 value is minus infinity. Logs are also very, very essential for calculus. Now, this is of the form 0 times infinity. So what we have to do is that we have to reciprocate one of them. Let's take an intelligent guess. This would probably give me a better answer if I reciprocate it. So let's reciprocate that. Limit of x goes to 3 from the right, log of x minus 3 over 1 over x minus 3 cubed. I can basically reciprocate it internally, and then it would become x minus 3 cubed, negative cubed. So basically, the thing is that when you take stuff on the denominator, the powers get flipped, right? That's all I did. Now, if you plug in the value of x, you get log of 3 minus 3 over 3 minus 3 of negative power. This becomes negative infinity on the top, 1 over 0 on the bottom, which is undefined. So now, because I have it in the form of infinite over infinite, which is an L'Hopital form, I can use the L'Hopital rules. So this becomes, now I can take the derivative of top and bottom. Limit of x goes to 3 from the right. This becomes log of x minus 3 over. So we're going to use the chain rule over here. First, let's look at it as a function alone. This is something raised to the power minus 3. So bring that power down and reduce the power by 1. Derivative of the inside would be just 1, so we don't really write it. Okay, let's take a derivative of the top also. The derivative of x log of x minus 3 would be 1 over x minus 3 times x. so we don't really write it. Moving stuff around, we get, so what would happen is that this would go on the bottom and this would come on the top. So over here, limit x goes to 3 from the right, x minus 3 to the power 4 over minus 3 times x minus 3. Now we can subtract one of those factors, and in the end I get limit of x goes to 3 from the right, x minus 3 to the power 3 over minus 3. Plugging in the 3 now, I get 0 cubed
So
over
fucking
minus 3, which is 0. Huh? Does anyone have a doubt? All right. I don't know if I can check it.
Okay, wait, I'm gonna ask a question. I'm gonna test.
Someone's
Okay.
mic is muted, and I think you might not realize that.
Sorry, I have a question.
Uh-huh.
How did x minus 3 to the third power become 0 to the third power?
You plug in the value of x over here. So 3
Oh,
minus
I
3 is
see.
0.
Thank you.
Yep. Mm-hmm. Thank you. All right. So, does anyone have a question in this before we move on to the next type?
No.
All right, then. Let's move to the next type. In this one, all we had to do was reciprocate one of them. So over here, like this over here, right? 0, so x cubed, right? And cot x is infinity. You would probably take the x cube on the bottom and perform the same operation over here. Moving to the next type, we have C infinite minus infinite. So let's look for one of those questions. Does this work? 1 over infinite is 1, no, so the lower one is 0 minus infinite. Okay, like, and n is one of them. N, limit of n goes to 1 from the right, 1 over log of 1, so log of x minus 1 over x minus 1. Always, my first task is to plug in the x. So I get 1 over log of 0, log of 1 minus 1 over x minus 1. Now, the value of log of 1 is 0. Log 1 to the any base is 0. 1 minus, and 1 minus 1 is also 0. So this becomes infinity minus infinity form. Now let's check what to do in these type of questions. Just give me 1 second. Okay. Now, let's take the original question. 1 over log of x, natural log of x, minus 1 over x minus 1, limit of x goes to 1 from the right. Now in these, what I have to do is that I have to take the common denominator. So let's try to merge them. I would have log of x times x minus 1 over here. So over here I would multiply the bottom and top by x minus 1. So I would have x minus 1 over here. Minus over here I would multiply by log of x on the top and bottom. Natural log of x. One from the right. Okay. Let's try to plug in the 1 now. So I get 1 minus 1 minus log of 1 over log of 1 x minus 1, 1 minus 1. So I get 0 minus 0 over 0 times 0. So I have the 0 over 0 form now. That means I can take the derivative of this. I can use I can apply the L'Hopital rule on this. So over here, derivating the top, I get 1 minus 0. So I would write it minus 1 over x. Log of x and derivative is 1 over x. 1 over x. Okay, I would need to apply the chain rule on, product rule on bottom. Derivative of the first one, leave the second one alone. Plus derivative of the second one, so 1, leave the second one alone. Doing algebra, I get x minus 1 over x, simplification. I get x minus 1 plus x times log of x over x. Moving stuff around, I get x minus 1 over x minus 1 plus x times log of x, natural log of x. Let's try plugging in the value of x again. So limit of x goes to 1. So now I get 1 minus 1 over 1 minus 1 plus 1 times log of 1. This again comes out to be 0 over 0 plus 0. So this is the 0 over 0 form. So I can apply the L'Hopital rule again on this. So over here this becomes limit of x goes to 1 from the right, which becomes, if now I can take the derivative on the top, I get 1 over 1 plus, doing the product rule again for x times log of x. Derivative of the first one, which is x, keep the second one alone, plus derivative of the second one, which is log of x, which is derivative 1 over x times x. This crosses out, becomes 1. So in the end, I get limit of x goes to 1 from the right, 1 over 1 plus log of natural log of x plus 1. If I plug in the value of x, I get 1 over 2 plus log of 1. Log of 1 is 0, so this becomes 1 over 2. And this is our answer. So all we did was that we made the denominators equal, reversed them, and then we plugged in the value of x and played with L'Hopital rule. Does anyone have a doubt in this? Or would you guys like me to move ahead? Anyone with any doubts? Should I go slower, go faster, anything?
You go a little slower.
A little slower?
Yeah.
But did you understand this?
Yes.
So let's move on to the next type, which is, the reason I'm not going slow is that because we have a lot of things to cover. If I go slow, then we won't be able to cover them in the total 3 hours, because we are already 50 minutes into the session, and after L'Hopital rule, we have these to talk about, and we have optimization, and we have the
Okay.
biggest topic ahead, which is antiderivatives.
And then I'll ask you a question when I have one.
Yeah, you can ask me a question anytime you want. And if we finish up early, you can even ask me questions in the end.
Perfect. All right, you just go. You're
Alright.
speaking.
Okay then. Now we have the fourth type, which is 0 to the power 0, infinity to the power 0, or 1 to the power infinity. Now these limits would be handled by logarithms. So that's why we need to learn logarithms really well. Let's pick one. Let's pick one example. Let's pick h. So h says limit of x goes to 0 from the right, sine x to the power of x. All right, now my first order of business every time is to plug in the value of x. So I get sine of 0 to the power 0, which is 0 to the power 0. So it is of the fourth form. Now what I need to do in these type of questions is that, let's first make it equal to 0. So y equals limit. 0 to the power 0 plus 1 plus 0 to the power 0 x goes to 0 from the right, sine of x to the power of x. And if we are applying limits on the both sides, they should be on the both sides as well. It won't do anything over here because the limit is being plugged in for the x. Okay, my next uh, thing to do would be to take log on both sides. So I get natural log of y equals limit x goes to 0 from the right, natural log of sine x to the power of x. Now, using log identities, I can bring this power forward. Limit of x goes to 0 from the right, x times natural log of sine x. Natural log of. Now, if I plug in the value of x, I get 0 times log of sine times sine of 0. So I get 0 times sine of 0 is 0, so log of 0, which is infinity. So I get no negative, which is negative infinity. So I get the form of 0 times infinity. And remember, what did we have to do in that form? We had to we had to make an intelligent guess and take one on the bottom. Basically reciprocate one of them. So let's reciprocate this one. We are basically linking all of them up to each other. This becomes the limit x goes to 0 from the right, natural log of sine x over x or minus 1. Now if we plug in the x, I get negative infinity on the top and I get an undefined on the bottom. So it would be of the type infinite over infinite, in which we can use the L'Hopital rule. So let's use the L'Hopital rule on this. We get limit x goes to 0 from the right. Now the derivative of log of sine x would be 1 over sine x times derivative of sine x, which is negative cos x. And the derivative of x to the power minus 1 would be bring the power down and reduce the power by 1. Adjusting stuff around, I get limit x goes to 0 from the right minus cos x. The x square comes on the top and the sin x goes to the bottom. We can take care of the negatives from here. So if I plug in the value of, what's my next step? My next step is to plug in the value of 0 again. So I get cos of 0, which is 1, x square over sine of 0. I get the value of 0 over 0 again. So that means I can use the L'Hopital rule again. Applying the L'Hopital rule over here, I get limit of x goes to 0 from the right. I have derivative of the first one, which is minus sine x, x square plus 2x times cos x over derivative sine x is negative cos x. So plugging in the value of 0, I get minus sine times 0, 0 squared plus 2 times 0 cos of 0 over minus cos of 0. I get 0 plus 0 on the top over minus 1. So the answer is 0. But we are not finished yet. Remember, on the left, I had a log of y. So I still have a log of y on the left. Natural log of y. So I get natural log of y equals 0. It can be also written as log of y with base e equals 0. If I open up the log, I get y equals e to the power 0, which is y equals 1. And that's my answer. 1. I know it was a lot. Does anyone have a question regarding this? First we took log on both sides because it was of the form 0 to the power infinity, 0 to the power 0. Then we derivated both of the sides. After that, I got 0 over 0 form. We derivated it again. And then I got to the answer as 0 from here. But we were not finished yet because we have a natural log on the other side too. So we open up the log and I get y equals 1. Is this clear with everybody? Anyone has any questions? How is the okay. The thing is that with the chat doesn't give me any rings or any like indications if uh I have a message or not. I'm curious, is this like a Q&A and then we work together, or are you going to problems the one you pick and teaching? So basically this is a review and I would be going over all the problems from the review sheet. Like not all the problems from the review sheet. I do host normal sessions in which you can come and do a Q&A with me. Okay. Does anyone have any questions? Don't worry. This is the best time to ask the questions. You don't if you're shy, don't worry. It's
I have
all
a question.
okay. Yes.
So how did you get 1 over sine times minus cosine? It's like
1 over sine times minus cosine. Okay. Over here, what I did was that I took the derivative of this because I got the infinity over infinity form. If I take a derivative of this, it would be 1 over something that was inside. And then using the chain rule, I have to derivate the something that was on the inside. So multiplying that, the derivative of sine x is negative cosine of x. And that's how I got it. Does it make that clear?
so on the inside is sine x.
Yep. So log of sine x on the inside. So
Oh, okay.
first we apply the rule of log, and then we actually derivate what's on the inside.
Okay.
Okay, perfect. Don't be shy to ask any questions. Right now is the best time to ask questions.
I have a question. Can you hear me?
Yes, I can.
So you might want over this. I zoned out for just a second, but
No worries.
when we are doing an equation and we get it, or we plug in the limit, and it's not
Mm-hmm.
something that is L hospitals or whatever his name is.
Okay,
It's not
yes.
like 0 over 0 or infinity over infinity.
Mm-hmm.
Um, depending on what we get, is there like actual rules for what we're supposed to do to get to the value that we can do L hospitals rule on? Or do we just like use our math knowledge to get it there?
So basically, there are four indeterminate types, right? If you get any answer other than those indeterminate types, then it would be a conclusive answer. So you can basically say that it's an answer to my question. But if you get any of the four indeterminate types over here, then the instructions on how to deal with them are given. So let's say if it's 0 over 0, then use the L'Hopital rule. If it's 0 times infinity, then you take one of those and reciprocate. If it's infinity minus infinity, after you plug in the 0, then you take the common denominator. And the 0 over 0 form is over here. You take the log on both sides. Basically,
Okay, yeah. It looks like you
yeah.
explained it.
hmm
Thank you.
hmm Basically, in math, we have just in our limited knowledge, we have just these four things that are problematic that we do not know what they are. And L'Hopital rule is giving us the method on how to solve those. All right. Does anyone have any other questions? If not, are we good to move ahead, or is there any question from 10 that you guys would like me to do?
We can move on.
Hmm?
I
We
think
can.
we can move on.
All right. So let's do that. If anyone has any question, you can tell me, okay? All right. So now that we are done with L'Hopital's rule,
Can you hear me?
uh, I can hear you. Yeah.
I'm sorry. I was speaking before, but my mic wasn't working for some reason, so I just had to refresh.
Oh, no
Can you
worries.
go back to limit approaching 0 to the right when it was cosine x times x squared? What was the denominator?
Sin X. That's my bad handwriting. I'm sorry.
Okay. Oh, so it was positive sine x. That's okay.
Yep.
I was just confused.
No worries. I'm gonna try to write better. All right. So let's move ahead. Next, we have section 4.5, which basically tells us what a domain of the function is, what intercepts are, what x-intercepts are, what even and odd is, what is periodic, what are horizontal and vertical asymptotes. Basically, this is preparing you for the next section. No, actually not. Oh yeah, this information is preparing you for basically 4.5 is actually graphing the graph. Now, as far as I know, well, some professors they would never like make you graph, but they would give you a graph and you have to identify the information. So I would go over each one of them what they are. Okay, and then we would do a question to actually graph a graph. Now, can anyone explain me what a function is according to their understanding? Like anyone, if anyone would like to move, come forward and like explain to me what they understand by by a function. I can turn off your voice from the recording if you are shy. No worries.
I just don't know.
Okay, that's a perfectly like acceptable answer. Okay, and, like I appreciate you telling me that. So now I can go ahead and tell you what a function is. Okay. Would anyone like to volunteer? I'm not gonna like ask any trick questions or anything. Just like for me to ask. I'm not gonna ask any mathy questions. Anyone?
Can you hear me?
I can.
So what is a function, right?
Yes. All right. So let's think of
Um,
function as a
oh,
juicer. Okay. Are we on the same page? No, I want you to answer me.
yeah.
So let's think of a function as a juicer. Now, can oranges go through a juicer?
Yeah.
Yeah, right. It would you would get orange juice. Um, Grapes would also give you some sort of juice, grape juice, right? Apples would give you apple juice. But can you put rocks through a juicer?
No.
No, right? It would break the thing. So the fruits that can go through your juicer, they're in your domain. Those numbers that work for your equation, that would give you a meaningful answer, that would give you an output, that is your domain. And your function is some machine that takes in numbers and spits out numbers. The range is basically what that function is capable to produce. So in case of a juicer, the range would be like the types of juices it can produce. It can make apple juice, orange juice, guava juice, heck, I don't know, cherry juice or something like that. Okay? Range would be the possibilities that function can have, the numbers that the function is like capable to spit out. So that's your range. And the numbers that work for your function, that does not make it not defined, that gives you a definite answer, that's in your domain. So domain is just a set of all those numbers, the part of all those numbers that work for my function. Function is just some machine that takes in numbers and spits out numbers, and range is the possibility of the numbers I can get from my function. With this, do you guys understand what a domain, a function, and a range is? Come on,
I
anyone.
think I think so. I think
It's pretty simple.
I guess.
Okay, now let's take a graph. What does intercept mean? To cross something, and the y-intercept is basically when the graph crosses the y-axis. So the y-intercept over here would be this. There can be at most one y-intercept, because if I have to cross the graph again, the y-axis again, right? If I cross the y-axis again, then it no longer becomes a function. It no longer remains a function with the vertical line test. So that was my vertical intercept. Next, I have my x-intercept. X-intercepts are the one that cross the x-axis. Those are your zeros. Next, I have even and odd functions. So even functions are the ones that if you plug in even negative numbers, they would give you a positive answer. How do I determine that? For that, what I do is that I plug in, let's say something like x squared plus x to the power 4, f of x. Let's try plugging in f of negative x, which gives me negative x squared plus negative x to the power 4. This would give me x squared plus x to the power 4 again, which can be written as f of x. Essentially, what even graphs do is that they're symmetrical above the about the phi axes. They're a mirror image of each other. In case of odd functions, let's say x cubed plus 1. Let's plug in the negative x in here. I get minus x cubed plus 1. Actually, not x. Let's take x. This would give me minus x cubed minus x. Taking the negative common, I get x cubed plus x, f of negative x. And I get f of negative x equals negative times f of x. These functions are symmetrical about the origin. So it would look something like this. If it's like this, it would reflect first from here to here and then from here down to here. So it would look something like this. These are odd functions. A function that doesn't look like either one of them is neither even nor odd. So let's say something like x cube plus x square, right? And I have f of x over here. If I plug in f of negative x, I would get negative x over 3 plus x square, because the even power would change the positive to a negative. Even if I take it, even if I factor a negative out, I get x cube minus x square, which is nowhere equal to anything I started with. So this is neither even nor odd. These don't show a symmetry. Periodic is when the graph repeats itself. So let's say graph is like this. Its periodicity would be this over here, the time it takes to repeat itself. Next, we have horizontal asymptotes. Before horizontal asymptotes, I would like to talk about vertical asymptotes. So basically, vertical asymptotes are the regions where my graph becomes undefined. Now, the line will get very close to -3, but it would be never -3. It cannot cross it. Those are my vertical asymptote. And horizontal asymptote is basically, let's say if my graph goes to infinity, it would look something like this. Something like this. So now, let's say my vertical asymptote is at y equals 0. So my graph would look like this. It would basically, there would be a spacing between the two graphs over here. Now, the maximum number of vertical asymptote is infinite. We can have as many vertical asymptotes we want. We can just keep dividing them. But the horizontal asymptotes can be 1. There can be either 0 horizontal asymptote, or 1 horizontal asymptote, or at max horizontal asymptote. Right. Are we good till here? Because after this we have just increasing, decreasing, and local maximum, minimum, and intervals of concavity and points of inflection, which we have already done. So intervals of increase and decrease, these are basically when the graph is increasing or the graph seems to be decreasing, which we have already learned. Local max and mins are the hills and the valleys. And the intervals of concavity, basically concavity is the shape of the graph. So if it's open towards down, concave down. If it's open towards up, concave up. Let's take a question to actually understand what they are. So all we have to do is now follow the instructions over here. So from 4.5, which question would you guys want me to do? Sketching the curve. Sketching the curve. I remember somebody asked me if we are doing sketching the curve or not. Pick one question, guys, from these three.
Can we do question 3?
Yeah, for sure. So question 3, right? X square over x square minus 4. Now, my first thing that I have to get is find the domain of the function. So to find the domain of the function, let's do a counterintuitive thing. Let's find the numbers that are not in my domain. The numbers that are not in my domain would be the ones that make the denominator 0. Let's factor it out. I would get x square over x square minus 2 squared. So it becomes x squared over x squared minus 2 squared. And I can use the identity a square minus b square, which is difference of squares, as this. So we get x square over x plus 2 and x minus 2. A is the domain of the function. Now, the domain of the function is basically, remember, it is the numbers that you can plug inside the question. To find the numbers that do not work for your equation, plug the denominator equal to 0. So, x plus 2, x minus 2 equals 0. I get numbers x equals plus 2 and minus 2. Positive and minus 2. Positive and negative 2. So, plus 2, minus 2. Now, these numbers on the bottom, they are your vertical asymptotes, the ones that go like these. So, my domain becomes minus infinity to minus 2, union minus 2 to 2, union 2 to infinity. Basically, these are the numbers that would give you a meaningful answer. Let's find the x and y intercepts. To find the x-intercept, right? What is the one thing we know about x-intercept? What is the y value at x-intercept? Would anyone like to tell
0.
me? 0, right? See the x value, the y value is 0 over here on the x-axis. So I would use that to my advantage. I have x square over x plus 2 times x minus 2. And I said that y value would be equal to 0. So 0 equals x square over x plus 2 x minus 2. If I multiply by x plus 2 and x minus 2 on both sides, I get x square equals 0, which is x equals 0. So one of my horizontal asymptotes is at, sorry, one of my vertical, no, one of my x-intercepts is at 0, which is 0, comma 0. For y-intercept, I would plug in, okay, so I have y equals x square over x square minus 4. At y-intercept, right over here, what would be the value of x?
0.
0, right? Because like x value is over here, right? Would be 0. So I plug in the value of 0, 0 over 0 minus 4, which is 0, which was the thing that I would get, because if I get my x-intercept equal to 0, that means this point over here, I'm also touching my y-axis. So it is bound that I would have a y value that is equal to 0. Okay? Give me just 1 second. Let me put one of my other earbuds to charge because I don't have any charge in it. Just give me 1 second. Okay. So as I said, that we would get one of those. If I get a x-intercept at 0, I would also get a y-intercept at 0. So I have one more information that my intercepts are at 0, comma 0. That means the line passes through the origin. The next is the function even or odd? To find that, I just plug in x equals, I just plug in negative x in the question. So f of x equals x square over x square minus 4. Let's plug in f of minus x. I get minus x square over minus x square minus 4, which is x square over x square minus 4, because we have even power. Now this is exactly what we started with. So it would be the same. So that means it is even. Easy, right? So that means it would also reflect on the y-axis like this. Something like that. Like it would be reflected on the y-axis. Finding the horizontal asymptotes of the graph. Does it tell me to find the vertical asymptote? Well, first of all, the vertical asymptotes, it has not told me to find, but we already know that the function is undefined at 2 and negative 2. So finding the vertical asymptotes is basically equating the denominator equal to 0. So vertical asymptotes are at they are at x equals to 2 comma minus 2. finding the horizontal asymptotes basically what we do is that we plug in the x equals to infinity. So x goes to infinity. Positive and negative infinity, we can say that. And the original function was x square over x square minus 4. Now, because we know the L'Hopital rule, we can use it over here. So if I plug in the value of x, I get infinity over infinity, which is an L'Hopital rule form. So let's take the derivative of the numerator, which is 2x over 2x on the bottom, which is just x, which is just 1. So limit of x goes to infinity, that is 1. That's odd. Actually, it is the same because it should be the ratio of their coefficients. Okay, so now I have 1. The limit of that would be 1. So I have an horizontal asymptote at y equals 1. Next is finding all the critical points. So basically, we have to find if the function is increasing or decreasing. Let's take the function again, x squared minus 4. Let's take a derivative of this. I get f of x equals f dash x equals. So let's use the quotient rule in this. I get so there's a rule for quotient rule that I like. Low d high minus high d low over low low. So taking a derivative of that. So low d high, that means write the low as it is and take the derivative of the high. So I get derivative of high as 2x minus high and take the derivative of the low. So get 2x over low low. So that means low squared. Simplifying this, I would get 2x cubed minus 8x minus 2x cubed over x squared minus 4 whole squared. This would become, so if I strike them out, I get minus 8x over x squared minus 4 whole squared. And that is my second derivative. Now my next step would be to equate the top and the bottom equal to 0. So I would get on the top I would have minus 8x equal to 0. I would have x equal to 0. That's one of my critical points now. On the bottom I have this equal to 0, and if I square on both sides I get x square equals, so x square minus 4 equals 0, which is x square equals 4, and x is equal to plus and minus 2. So from this I have 0, 2 and minus 2. But remember, I must always look at my domain. From my domain, which is all the way up over here, over here, I cannot have negative 2 and 2 as my answers. So I would reject these two numbers from here. And the number that only survives is 0. So the 0 is the only one that I would be testing for my critical numbers. Now let's find the local max and min values. So let's make a graph. And it's not a line, it's a number line. And let's plug in the critical value, which is 0. Now, can anyone pick a number below lesser than 0 for me? Anyone?
-1.
-1. Okay. So, if you plug in -1, let me factor it out and give a better. Okay, over here. If you plug in -1 over here, let's say this is -8, -1. Okay, if you plug in -1 just over here, what do you get? Positive or negative?
Positive.
Yes, right. Negative times negative is positive, right? And on the bottom, because we have a square, this will always be positive. Sorry guys, that was my friend goofing around. I'm sorry. Okay, so this would be a positive on the top. And on the bottom, because this is a square, this is an even value, it will make anything positive if I plug in anything. So this region over here would become positive. Now, can anyone pick a number bigger than 0 for me? Come on, anyone. Number bigger than 0. Anyone? Come on.
Come on. 1. Come on, guys.
1, yes. So if you plug in 1 over here, do you get a positive or a negative?
Negative.
Negative, right? And it always stays positive on the bottom. So you get negative over here. So according to my shortcut, if you're going from positive to negative, right? You would get a local max over here. So you look on the left. It's a positive, so local max. So 0 is local max. That critical point is a local max. Let's look at what else do they want. Increasing, decreasing. Okay, so increasing would be the positive regions. So this would be minus infinity to 0. And decreasing would be 0 to infinity. Next, we need to find the intervals of concave up or concave down. This is the last thing that I need to find before I am able to sketch my graph. So let's take another derivative of this function over here. Let me bring it down. Okay, so if I take a derivative of this, I will again apply the product rule. Sorry, not the product rule, the quotient rule. So I would get low d high, so keeping the low the same. Derivative of the high, so I get minus 8. Minus high, keeping the high the same. Derivative of low. So derivative of low would be using the chain rule. So 2 times x square minus 4, reduce the power by 1. And the derivative of the inside is 2x over x square minus 4, and the square of that would be 4 again. So I get x square minus 4 minus 8 minus 8x, and over here I get, okay, this became a very big derivative over here. 2 times x square minus 4 times 2x over x square minus 4 to the power 4. Let's think if I can get a way to make this simpler. Let's first start by multiplying the constant. So I would get like 2 times 2 times this 4 times 8 is 2 times 2 is 4, 4 times 8 is 32. So I would get 32 over here. And x times x would be x squared. This would make it plus over here. So it reduces to this. And from here, let me factor in one of the x square minus 4s. So x square minus 4 factored out. From here, I am left with x square minus 4 times minus 8 plus. From here, I'm left with 32 x square over x square minus 4 to the power 4. I get x square minus 4, and on the inside, I'm getting minus 8x square plus 32 plus 32 squared x squared. I would get 24x square remaining over x square minus 4 to the power 4. All right, now let's FOIL it out. Damn, this thing became very big. Let me consult my guide. Am I doing something wrong? We are doing 11.3. Part 3. Oh yeah, we can take care of one of these. This becomes 3, and I have 24x square plus 32. Wow, amazingly that we are doing it all right. That's crazy. I don't expect this to come in your exam because this would be insane to deal with in an exam. So, factoring out the 8, I mean, a question like this would come out, but not this specifically. That's what I think. Don't quote me on that. If your professor feels funny, he can put that into. Okay. Now, same thing. Derivate the top and bottom equal to 0. So you get 0 equals 8 times 3x square plus 4. So you'll get minus 4 over 3 equals x square. And you can't really take a like a square root of a negative number. So we'll forget about this. Let's talk about the one on the bottom. So x square minus 4 equals 0. This becomes x equals plus and minus 2. Now, look at the domain again. So again, we won't have any points of inflection, but we will still use them for our number line. Okay, I did something wrong over here. Over here, even if we don't have them as critical points, we still consider them for our number line. That's one correction that I would like to do. Over here, I would still consider them for my number line. I would just keep them on an open interval. They won't become my maximum and minimums, but I would still have them on my number line. So if I put a number smaller than -2, right? Plugging in a number -2 over here, I would get positive. I would get positive again, then negative and negative again, because this switches around the sign like we observed, and this gives the positive. Doing the same on the bottom, I have -2 and 2, which are on an open interval. Putting a number smaller than 2 inside of, let's see, this function. Let's duplicate this. Let's pick a number smaller than 2. Let's pick -3. If I plug in -3 over here in the inside of this x square, it will give me a positive answer. And if I plug it over here, it would give me, okay, -2 square is 4. So -3 square is, this would give me positive. So it would be positive over here. Positive over here. Now let's pick a number between -2 and 2, which is 0. Plugging in 0 over here, I get positive. Over here, I would get negative. So the middle region becomes negative. And if I plug in a number bigger than 2, let's say 3, positive always over here. And 3 squared would be 9. 9 minus 4 is positive. So this would be positive. So I get this as my region. Now it would be concave up from -infinity to -2. Union 2 to infinity. And it would be concave down from -2 to 2. Now we have all the information that is required to plot the graph. Let's make the graph. Okay, let's pick the vertical asymptotes first. So -2 and 2. 2, -2, and we also have 0. So the first thing would be to plot out the asymptotes. So I have an asymptote over here. I have an asymptote over here. And also I have a horizontal asymptote at y equals 1, I think. Yep, we have a horizontal asymptote over here, y equals 1. So if I have 1 over here, 1, I have a horizontal asymptote over here. Now I need to make combinations. So let's pick this region over here, -infinity to -2. So -infinity to -2 is concave up. So it's like this. I can have 4 possibilities, like this. This is increasing. These are increasing. So this is increasing. This is increasing. This is decreasing. This is also decreasing. This is concave up. This is concave down. These over here are concave down. These over here are concave up. Now, over here, -infinity to -2 is concave up. And -infinity to -2 is also a -infinity to -2 is also increasing. So, concave up plus increasing. Concave up plus increasing. It is this one. So, it would look something like this. Like this. Similarly, we also have an intersection point over here. So the graph would touch over here. From -2 to 0. So -2 to 2, I have concave down. And I also have, okay, for the first part, it is increasing, then it's decreasing. So first increasing, concave down and decreasing. So it's over here like this. Actually, concave down and increasing. Yeah, like this. Concave down and increasing. And then concave down and decreasing. So like this. Now in the last one, from 2 to infinity, I have concave up and I have and we have decreasing. So concave up, concave down, concave up and decreasing is this one. So I have it like this. So this is how I would graph my equation. I know this was huge. Does anyone have any doubts in this? Remember, this is the perfect time to ask for doubts. Don't be shy.
No.
All right. So this was basically following what the question wants and then using the knowledge we have to plot the graph. Step 1 was to plot out the vertical asymptotes. Step 2 was to make this chart over here and then mix and match what to do over here. Okay, next. Next we have optimization. So in optimization, basically what happens is that let's say we pick 13 bird sanctuary. Basically what happens is that you have to either find a maximum or a minimum, and you have to prove that it is the only local max or min, so that would be the absolute max or min, and you would have a connecting function. So let's take an example in this one. A rectangular bird sanctuary, 300 square feet in area, is to be fenced off against squirrels. So it's rectangular. The first thing is to always draw it. It is 300 square feet. Find the dimension that will require the least amount of fencing. So we have to find the absolute minimum. Given that one side of sanctuary is protected by Dr. Miller's house. So this is protected by Dr. Miller's house. So we only need to fence this area over here. Okay. We can take this as x and this as y's. Now from this I know that area of of a rectangle is x is length times breadth or length times width, which is 300. And the perimeter of this fences thing over here would be x plus y, which I need to find. I need to find the local minimum. I mean the absolute minimum. So f of x, now the perimeter is this. We need to find the local minimum of this. Let's get rid of the y. Okay. So we can write the y as y equals 300 over x. This will become x plus 2 times 300 over x, which would be x square plus 600 over x, f of x. Now to find the local minimum, what we would do is that we would take the derivative and find the critical point. F dash x, the derivative would be, let's use the quotient rule. Low d high, so low is kept the same, derivative of high would be 2x, minus high is kept the same, d of low would be 1 over low, so low is x squared. I get 2x squared minus x squared plus 600 over x squared, f dash x. From this I get x squared plus 600 over x squared, which is this first derivative. Now to find the critical points, all I need to do is that I need to keep the numerator and the denominator both equal to 0. So x squared plus 600 equals 0, which from which oh actually this turns to negative. So I get x square equals 600. X equals square root of 600 as one of the points. And I would also keep x square equals 0. X equals 0. This is the second critical point. Now tell me, can length ever be 0? Could anybody tell me that? Let's say I want to make a rectangle. No, right? So, well, let's just theoretical think that. Okay, let's just consider it for now. Okay, let's make a number line. I have a better question. Can length ever be negative?
No.
No. So we would disregard the portion before the 0, and we have square root of 600 over here. Now pick a number smaller than square root of 600.
1.
1. Perfect. Okay. So let's plug in 1 over here. Okay. Plugging in 1 over here, do you get positive or negative?
Negative.
Negative, right? Negative over positive. So that is negative. Pick a number bigger than root 600.
I don't know, like 1,000?
1,000 works. Okay. 1,000 over here, positive or negative?
Positive.
Positive. And over here, positive again. Positive over positive is positive. So now, as you can see, the thing before it is negative. It goes like this, decreasing and increasing. So this is a local minimum. What is the thing we require? We want the least of that thing. So this is the local minimum. Now now attention towards here. This is absolutely necessary in optimization questions. You need to declare the local minimum as the absolute minimum, that it is the only minimum that you have. Okay? For that, what we would write is that since lengths cannot be negative and this is the only local minimum we have, therefore this is also, so we would say that square root of 600 is the local min, also the local max. So absolute minimum. Absolute minimum. So absolute minimum, that means for the whole equation, this is the smallest value, is square root of 600. X equals 600. Okay? Now we need to find the y value. To find the y value, just use the relation that was given in the starting. Y equals 300 over x. So y equals 300 over square root of 600. If I want to be clever, I can just do 600 over 2, which is square root of 600 over 2. So these are your answers. These are your dimensions. X is square root of 600, y is square root of 600 over 2. Let me see what the question is asking. The question is asking, find the dimensions. Okay, so we have the dimension. If it wanted us to find the perimeter as well, we can just plug it into the perimeter formula. So, which was like 2 y's and 1 x's. Is this clear?
Yes.
So basically, what we do is that we have a connecting function, and then we find either the local max or local min according to the question, and then we declare that the thing that we found is the only local min or max. So it is the only absolute min or max depending on the question, and then you proceed further. All right then. With that, should we move on to the last topic of this session, which is antiderivatives, which is the largest topic ahead? Should we move on, or does anyone have any questions on any topic before this? L'Hopital, anything, doesn't matter. This topic, any topic before this. If not, let me know if we can go ahead.
I don't have a question.
All right then. Let's move ahead and start with antiderivatives. Now, the first thing in antiderivatives is that you need to know this table. Okay, learn it to your heart, spend like an hour, 2 hours, whatever it is. You need to learn this because if not in Calc 1, you would absolutely need to know them in Calc 2. Okay, so there is no escaping and remembering them. Just letting you guys know. Just like the unit circle table from pre-calculus, this will stick around from the rest for the rest of your calculus. A function f. Okay, now let's understand what antiderivatives and an integral is. Now, let's take a graph and let's make a line. If we remember, what was a derivative? What did it what did it graphically give me? Could anybody tell me again? What did the derivative give me again?
Like the slope of tangent.
The slope, right? So basically zooming into that point and giving me the angle of that specific angle of that point. That was derivative. Integration or antiderivative is the exact opposite of that. It is zooming out and giving me the area under the graph. Okay? All antiderivative gives me is that the area from one specific point to the other specific point under that graph. Okay? Antiderivative, area under the graph gives me the area over there. The most precise area that it can give us. Do we understand that?
Yes.
Perfect. So, well, that topic has been given at the end of your syllabus, but I would like to discuss it now. Now, like in derivatives, right? We started by derivating by using limits, right? Similarly, there is an elementary way over here to ease your way into antiderivatives. Let me get to that topic. Okay. The topic is Riemann sum. So let's say I have a graph like this, okay? And I want to get the area of the graph under the graph from here to here. Well, one way is that let's split this uh, function into squares, into rectangles. Like this. Now, do you think if I get the areas of these rectangles, right? Would it be roughly equal to the area under the graph? Do you think that?
Yeah, I think so.
Yeah, right? I mean, obviously we would have inaccuracies, but we can improve those inaccuracies by increasing our resolution. Ultimately, what would happen is that we would have so many rectangles that it would ultimately shape the curvature of the graph. That is the idea. But right now we are starting with the elementary elementary way to get the area under the graph. So basically, we use the method called Riemann sum. In Riemann sum, we have an n which is was something like x minus b upon these were like x minus a minus b, b minus a upon n, something like that. Yeah. So we have a delta x which was b minus a upon n. So basically, like the b, so basically the b distance from the graph minus the a distance from the graph upon how many rectangles we want. That is basically how many partitions we want. Okay. Let's go to the question so that I can explain it better. Let's pick 25. 25. In this we have fx equals 3 plus 3x squared. From my a point is 1, my b point is 4, and n is 6. So delta x is 4 minus 1 upon 6, or 3 upon 6, which is half. So this gives me that there should be spaces of half starting from 1. So it would be like 1, 3 over 2, so like 1.5, 2, 2.5, 3, 3.5, and 4. Starting from here till here, I have 1, 2, 3, 4, 5, 6, 7. Notice I have one extra. Now, to find the left endpoints, what you do is that, actually, let me review again. Okay, you keep the delta x on the outside, and you basically plug in these numbers. So if you want to find it from the left, you only look at the left values, 6 left values. If you want the right, you only look at the right 6 values. And if you want the midpoints, then you take the middle 6 values. Basically, what we are doing over here is that the delta x is the space between the rectangles, and the f of x is the y over here. So we are basically getting their individual areas and we are adding them up. That's all we are doing. So f of 1, f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5. Delta x is 1 over 2. This would be my left endpoints. So that would give me an answer of, let me save time and get it from my sheet. This is 25. This is 20. 3 plus 3x squared. Okay. So this would give me an answer as 61.125. Taking the right endpoints, which is basically taking these over here, which would be 1 over 2 times f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5 plus f of 4. And this would give me the answer of about 84.125. The third would be the middle one. For the middle, I take the points in the middle of it. So basically 1.25, 1.75. Oh, next one is 2.25, 2.75, 3.25, and 3.75. Battery ran out of my earbuds. Give me 1 second. Okay. Let me connect. Just give me 1 second, guys. Okay. Let me see if I'm getting. Okay. Can somebody speak and tell and check if I can hear them? Anyone can someone help me and speak? Actually, I can do it on my laptop. Seems like it's working. Okay, let me know in the chat if you guys speak and I couldn't hear you. All right, let's not waste time further and move forward. Okay, so the middle points would be basically taking them. So half, which is the delta x, f of 1.25, f of 1.75 plus f of 2.25 plus f of 2.75 plus f of 3.75 plus f of, okay, that was the 3.25 plus f of 3.75. This would give me an answer of 71.8125. So this was how to do the Riemann sums. You would definitely get one of those questions in the exam. All you have to do is find the delta x, split up the number line into the number of n, and then if you want the f, look from the left. If you want the right, look from the points from the right, and if it's the middle, then the middle points. Does anyone have a question, or should we move forward? Because we have 54 minutes and I want to cover antiderivatives completely in this session. Okay, then I'll be moving forward and finishing up with the antiderivatives. Okay, now that we know that this is the elementary way to get the antiderivatives, we obviously won't be using this to get all of them. We have some antiderivative rules. So first of all, let me introduce you guys to the integrand. Now the integrand is a big S. It has a starting point and it has an ending point. And it has, let's say it is fx, it houses a function inside, and this is the end of the integrand. So you can think of this as two parentheses. This is the start of the integrand, this is the end of the integrand. This x over here, the variable after the d, it defines that for what variable this integrand will work for. This would get us the area under the function, area under the graph. Basically, derivative would be going this way, f dash x, f double dash x. The integrand will move us back. So if I take antiderivative of f double dash x, it would get me back to f dash x. F dash x would get me back to fx. Now there are a few theorems. The first one is a to a fx dx. And this is quite self-explanatory. If my starting and end points of measuring the area is like if they are the same points, then the area would be 0, right? Because one of those points is 0. A line doesn't have any area, so this would be 0. B says if you want to reverse the limits of integration, the bounds, then the integrand will revert and there would be a negative placed outside. Third one is that you can take constants out of the integrand, or basically if there is a constant, you can take if you take a derivative of constant, there will be the x attached with this. Why does this happen? So let's say if you have c times, before that I need to introduce you guys to how to take the derivative. Okay, if I have something like x square and I want to take its antiderivative, what I do is that I increase the power by 1. Its power rule is increasing the power by 1 and dividing with that power. If it's an indefinite integral, that means if it doesn't have pounds, then we put a plus c on the outside, which stands for a constant. This is how you would find this is a very basic of integration, increasing the power by 1 and then dividing with that power. Next, let me actually just open the document up. So, and everything that you would expect them to be, it would be like that. The derivative of constant is uh, basically you put an x inside and then we do b minus a. I would explain that later in the later questions. If you have two functions adding, the integrand can go to separately one of them. Constants come out of the integrand. Next, you can split an integrand into two parts. So basically, let's say you have a big integrand like this from here to here. You have a and b. Let's say you want to get this area over here, and I introduce a third variable in it called c. Now, the total area over here would be just this area and this area, right? This would be integrand of c from a to c fx dx plus integrand of c to b fx dx. So this is how you can just split a integrand. Moving on, these are pretty self-explanatory. If the function is greater than 0 for a to b, then the integrand would be the antiderivative would be 0. If a function is greater than another function from a to b, then the antiderivative of those functions would be the same as well. These were the properties of antiderivatives. You would understand better if we just do the problems regarding it. So if I go to antiderivative problems over here from 19, okay, pick a few questions from 19. Which would you guys want me to do? Hello, guys. Come on, pick questions.
K.
K? Okay, let's do K. Now, since you are in Calc 1, you won't be going that far into antiderivatives. These would only require with some tricks to solve, some algebraic tricks. So what I can do is that I can split I can split these apart. This becomes f of x equals cos cube x over 4 cos square x minus 6 over 4 cos square x. I can factor it out. I mean, I can delete the duplicate factors, which is this becomes cos x over 4 minus 3 over 2 secant square x. Let's take an antiderivative of this. So the antiderivative of this would be like this, secant square x. We know the constants move outside. So I can move the constant outside. This becomes cos of x dx minus 3 over 2 secant square x. So if I consult my table, the antiderivative of cos x should be sin x, 1 over 4 sin x. And I think the antiderivative of secant square x is tangent x, I think. Yep, so antiderivative is tangent of x. So 3 over 2 tangent of x dx. Sorry, not dx plus c. Is that clear? We are just using algebra and using our basic identities. Yes. Okay. All right then. Guys, do you have any specific questions to pick from this? Or do you want me to pick some? Come on. All right then, I'll pick some on my own. Let's do 19b. Let's start with a simpler one so that if somebody is struggling with those, they can know how to do it. 19b says f of x equals 12x squared plus 6x. The antiderivative would be, so if I take the antiderivative of 12x squared plus 6x dx, first the integrand can go to the other one as well. So if I keep it like this over here, the integrand will get spread apart. Now the constants can come outside. And finally, I can apply my basic antiderivative identity. So increase the power by 1, divide by that power. 6 times increase the power by 1, divide by that power. Plus c. This becomes 4, this becomes 3. So I have 4x cubed plus 3x squared plus c as my answer. That's the most general antiderivative. Remember to never forget the c if you use an antiderivative, if you use indefinite integrals. Next one, let's do
Sorry,
D.
do you mind scrolling back up real fast?
Yep,
Thank
for
you.
sure.
Okay, I'm good. Thank you.
Perfect. All right. Let's move to D. Now, D is a specific identity from your table, which is this one over here, b to the power x. Where's b to? Yeah, b to the power x. So b to the power x over log of b. So antiderivative of this would be 6 to the power x over natural log of 6. That's it. Let's do let's do G. I will pick 2, 3 more and then I'll move on to the next questions. Okay, what do we have actually as more of our questions? So I have 20, I have 21. Okay, not that much left. Let's do G. F of x equals x plus 1, 3x squared plus x. So f of x would be x times 3x squared plus x and x plus 1 times 3x squared plus x, which would be 3x cubed plus x squared plus 3x squared plus x. You'd get 3x cubed plus 3x squared, sorry, 4x squared plus x. Now let's take the antiderivative of this. Taking the antiderivative of this, I would get, so first it would spread into all of them. Then the constants can come outside. So I would get 3 times x to the power 4 over 4 plus 4 times x to the power 3 over 3 plus x to the power 2 over 2 plus c. That would be my answer. Then now all of these are just basically simple algebra, and then applying our basic property of antiderivatives. Okay, I'll do one more. Do you guys want to pick one more? Yes, just one more. Come on.
Wait, sorry, I have a question.
Mm-hmm.
So after you separate like 3 with the antiderivative sign, how did you plug it back in for f of x? Like, how did you get 3 times x to the fourth over, is that a 9?
Oh, it's not a 9, it's a 4.
Oh, a
So
4.
basically,
Okay.
what happened was that I got the antiderivative of this, and this was just outside. So it's like this. And these are the antiderivatives. Does that answer your question?
Kind of. How, but like, how are we getting x to the 4 over 4?
Okay. Now this uses the basic antiderivative rule that if I have something raised to the power n dx, right? I would get its antiderivative by increasing the power by 1 and then dividing by that power. That is what I did over here. I increased the power by 1 and then I divided by that power. Like for derivatives, right? For derivatives, we decrease the power by 1 and add it to and put it to the front, right? Like if we have something like x to the power n, we bring the power down and decrease the power by 1. That's how we do derivatives. For antiderivatives, it is different. In this, we increase the power by 1, and instead of multiplying, we divide with that power. Okay?
Okay, got it. Thank you.
Perfect.
Can you
All
work
right.
H?
H? I can. All right. Let's do H. And after that, I would be moving forward. Unless if you guys would have any more questions. Now, H is all about like understanding what powers really are. square root are Rayleigh's powers. So square root can be written as x to the power 1 over 2 plus 5 times. I have x square in the inside. Now, cube root of x can be written as 1 over 3. So this can be written as x to the power 1 over 2 plus 5 times x to the power 2 over 3 of x. Okay? Now, let's take the antiderivative. So, increase the power by 1, divide by that power. 1 over 2 plus 1, that would be 3 over 2. So, x to the power 3 over 3 over 2 plus 5 times 2 over 3 plus 1, that becomes 2 plus 3 over 3, which is 5 over 3. So, x to the power 5 over 3 over 5 over 3. So, 2 times x to the power 3 over 2, 3 over 2 over 3 plus 3 times 5 x to the power 5 over 3 over 5. The 5 and 5 cancel out. I can just get 2 over 3 x to the power 3 over 2 plus 3 times x to the power 5 over 2, 5 over 3 plus c. That's my antiderivative. Any questions in the simplification? I understand that this can be quite challenging to wrap your head around. If you have any questions, just let me know. Okay, guys, should we move ahead? Guys, we gotta communicate. Anyone? Do you have any more problems regarding this, or should we move ahead?
Could you just quickly go over like the full process of
Yeah.
taking the antiderivative of square root?
So basically, what I did was that a square root is basically something raised to the power 1 over 2. And a cube root is raised to the power 1 over 3. They are fractional powers, the roots. Now over here, because I had a square on the inside and a fractional power on the outside, power on the inside, power on the outside, powers multiply together. So this becomes x to the power 2 over 3. This over here becomes x to the power 1 over 2. Taking an antiderivative is increasing the power by 1 and then dividing with that power. If I increase 1 over 2 by 1, which is 3 over 2, becomes x to the power 3 over 2 divided with that power. Next I have x raised to the power 5 over 2 over 3. 2 over 3 plus 1 is 5 over 3. So divide with that power, increase and divide with that power, right? Next is just algebraic next is just algebraic, how do I say it? Simplification. So the 2 is over here, it goes on the top. The 3 is over here, it goes on the top. 3 is over here, 2 is over here. I had 5 and 5 common factors, so I cancel them out. And this is what I'm left with. Does that answer your question? Or would you want me to explain some specific part?
That's fine, thank you.
All right. So with that, let's move forward to 20. So in 20, what we are doing is that we are constructing the functions back up, going back. Okay, let's do 20a. If I have f dash x equals 8 and I'm also given that f of 9 is equal to 2. Okay, now f of x equals 8. Let's take an antiderivative. Taking the antiderivative f of f dash x, I would get f of x equals 8x. Remember the formula in the property, if we have a constant, if we antiderivative it, I get uh, I get a x with it outside plus c. Now I need to figure out what this c is. I've been also given that f of 9 is 2. So let's plug that in. F of 9 equals 2. F of 9 is 8 times 9 plus c equals 2. 8 times 9 is 72 plus c equals 2. C is negative 71. Sorry, negative 70. So my c is negative 70. F of x is 8x minus 70. Let's do some more. Let's do... Do you guys have any specific in mind? I'll do C for now. F dash x has been given as 6x plus sine x. F of minus pi equals minus 6. Ooh, looks like a big one. But actually it's quite simple. Excuse me. Alright. So, all we have to do is to go to the original equation by taking an antiderivative. So, f of x would be the antiderivative of 6x plus sine x dx. We can take the antiderivative separately of them. Over here, the constant would move out. This would become 6 times x to increase the power by 1 divided by that power. Plus, the derivative of sine x is negative of cosine x plus c. That's my f of x. I have been also given, again I have been given that f of minus pi is minus 6. So you will be always given something to figure it out. F of minus pi equals minus 6. So plugging in minus pi, 3 times minus pi squared plus minus cos of minus pi plus c equals minus 6. This becomes 3 pi square minus cos of minus 5. So cos of minus pi, so it goes from here to here. That would be negative 1. So negative becomes positive. 3 pi square plus 1 plus 6 plus c equals minus 6. The way I did the cos minus pi is that so if this is a graph and cos is 0 over here, sorry, 1 over here, 0 over here, minus 1 over here, 0 over here again. And I'm going minus 180 degrees, so it would be minus 1. It would be minus 1. Going minus 180 degrees, so it would be minus 1. Now, this becomes c equals minus 6 minus 1 minus 3 pi square. C is minus 3 pi square minus 7. So this is my c. All I need to do is put it over here. So fx equals minus 3x square minus cos x minus 3 pi square minus 7, and that is my final answer. Does anyone have any doubts? If not, then we can do some more questions. Let's do E. E is very important. F dash x equals 3 over 1 plus x square, and f of 0 is minus 6. So let's take the antiderivative of this. 3 times 1 plus x square. Constants can come outside. And if we look at our chart, 1 over 1 plus x square is arc tan of x. This is very, very, very important. Arc tan of x comes 3 times arc tan of x plus c. We have been also given that f of 0 is minus 6. So minus 6 equals 3 times arc tan of 0 plus c. Arctan of 0 is 0, so I'll get c equals minus 6. The answer I get in the end is f of x equals 3 times arctan of x line minus 6, and that's your final answer. So it's always just taking the antiderivative and then figuring stuff around. All right, let's do one more. Let's do G. F double dash x equals 5e to the power x. F dash x, so f dash 0 is 1 and f of 1 is 2. If we take an antiderivative of this over here, if I take an antiderivative, I would go to f dash x equals antiderivative of 5e to the power x, taking the constant outside. The derivative of e to the power, antiderivative of e to the power x is just e to the power x, so 5 times e to the power x plus c. Now I have been given that f dash of 0 is 1, so f dash of 0 is 1, so 5 times e to the power 0 plus e to the power 0 is 1, so 5, 1 equals 5 plus c, and c is negative 4, so I will plug in the c over there. So far f dash x is equal to 5 e to the power x minus 4. Let's take an antiderivative again. So I get f of x equals antiderivative of f5 e to the power x minus 4 dx. Let's spread the integrand and the integrand apart. So this becomes 5 e to the power x minus integrand of 4 dx. Taking the constants again outside, I would get 5 e to the power x stays e to the power x minus, because it's just a constant, it would acquire an x, plus c, that's f of x. And I've been also given that f of 1 is 2, so 2 equals, when I plug in 1, so I get 6 minus 5e equals c, and that's my c. So my answer is f of x equals 5e to the power x minus 4x plus 6 minus 5e. That's my answer. Does anyone have any doubts? Okay then. Now moving on to the last topic of today. Word problems. Now word problems are pretty much what we did over here, just in the form of words. If we remember from previous exercises in our, I think in our first test, if we take a derivative of displacement, it changes into velocity, and derivative of that would change into acceleration. Same thing would happen over here, but antiderivative moves it backwards. So velocity to acceleration to velocity and velocity to displacement. So let's do 21. All of them have the same thing, but let's do 21. From the top of a stage located 80 meters high in air. So height is 80 meters. Jason throws his mic upward with an initial velocity of 10 meters per second. So he's over here and he threw the mic up with velocity 0 equals 10 meters per second. And the acceleration due to gravity is minus 9.8 meters per second. Acceleration is minus 9.8 meters per second square. Find the distance of the mic above the ground at any time t. So basically we have to go to s of t function. You have to find that function. Let's start with the function that has been given to us, acceleration. So acceleration is equal to minus 9.8. Let's take the antiderivative of it. I'll get to velocity. Antiderivative of it would be just, because it's a constant, right? It would have a variable outside. So minus 9.8 t plus c. We have been given that velocity when it's 0 is 10 meters per second. So v of 0 equals 10. That means 10 equals minus 9.8 times 0 plus c, and c is 10. So my velocity function becomes vt equals minus 9.8 t plus 10. And the last step is to go to the displacement function. So s of t, its antiderivative would be minus 9.8 t. So this is t and this is plus 10, right? Now I can move the integrand on both of them and I can take the constants outside. Antiderivative of t would be increase the power by 1, divide by that power, plus 10t plus c. Because this was just a constant, it's left like that. This would become 4.9 minus 4.9 t square. So minus 4.9 t square plus 10t plus c s of t. And I have been given that at s of 0, the height is 80 meters. So basically, when I plug in 0, I get 80 meters. So s of 0, when time is 0, it is 80 meters. So 80 equals minus 4.9 times 0 plus 10 times 0 plus c. So c is 80. So my final displacement time function is minus 4.9t plus 10t plus 80. This would give me the displacement at any time point t. Next is, how long does it take for the mic to reach the ground? So basically, to find how long it takes to my mic to reach the ground, what is the distance between the ground when the mic hits it, between the mic and the ground? When something hits something, the distance becomes 0, right? So basically, I need to find the time t when the distance is 0. So I need to find the time t when the distance is 0 between the mic and the ground. S of t has been given us, we found it to be minus 4.9t plus, t squared. Yep, t squared. Plus 10t plus 80. Now, we are going to use the quadratic formula. Okay? Using the quadratic formula, I get minus p plus minus square root of b square. So 10 square minus 4 times minus 4.9 times c 80 over 2 times minus 4.9. That's going to be my times. So let me actually pull up a calculator. Over here. So minus 10 is to plus square root of 10 square minus 4 times minus 4.9 A times C over so if I keep everything in a parentheses, I want to make it something like this. So over 2 times minus 4.9. Hmm. Mm, 2 times A times C. So I'm getting minus 3.147. And if I do if I do minus over here, then I get 5.12, 5.187. So 1188. Now, time can never be negative. So I'm going to reject this value. So the value I get is 5.188 seconds approximately. What is the velocity when the mic hits the ground? Now we know when the mic hits the ground. So all we need to do is now plug this time back into the velocity function. Velocity of 5.188 equals, so velocity function was minus 9.8 times minus 9.8 t plus 10. Minus 9.8 times 5.188 plus 10. So I would get minus 9.8, 5.1. Plus 10. So the velocity was negative 40.8424. Now it's going to be negative because the object was moving down. So we can say velocity was 40.8424 downwards. So as you can see, it was basically 20, but just in question forms. So like word problems forms. 22 and 23 are basically the same. And with that, we should be done with our review. Does anyone have any questions in any part of the review or any question that they have in general? This is a very good time to ask. Is everything clear? I know this was a bit fast, but I wanted to cover everything today so that there is a complete concise guide for everything. Alright then, in that case, if nobody has doubts, I would be going ahead and stopping the recording today. Thank you so much for joining in for this test review 3, and I hope that you score good on your exam.